Good afternoon. Today we will see Unit 3 Repair Materials. So in this we will see about corrosion control materials. So in last unit we seen about damage assessment. So what process we have to follow to identify a damage in a building. So based on that what are all the tests we have to do, mainly the NDT test for the strength for corrosion assessment and for overall structural integrity. So we seen in detail about those NDT test, and based on that we will come to a conclusion that this is the damage occurred and it is a structural crack or non-structural crack. Now we have to choose a repair material. So the most common failures which occurs on building are due to corrosion. So in today's class we will see what are the different materials available and what concepts which deals with the corrosion control mechanism. So this is the outcome of this unit, to know about different type of repair material. So, so this is a quick revision. So in the first unit we seen about the corrosion mechanism. So how it is happening means, so that should be an environment where three components, namely the anode, cathode and electrolyte. So anode will be one part of an steel rod, and another part will act as cathode, and the medium, that is the concrete surrounding which is wet, will act as an electrolyte. So in that the transfer of electron will take place from anode to cathode, and a deposition of ferrous hydroxide will happen, which is nothing called as rust. So this one is a quick revision of the corrosion mechanism which we studied in the first unit. So with this idea we will see what are all the control methods. So actually this corrosion control can be done at the starting state itself when we are planning and design. So our IS code also, that is IS 456-2000, tells about the cover depth which is should to be provided for various exposure condition, that is mild, moderate, severe, very severe and extreme condition. Extreme condition means we can give a cover depth of 75. So it has been to be decided in the planning state itself what type of environment is that, so that what type of cover we have to provide it. Normally for a slab we will provide a cover of minimum of 15 mm, for beam 25 mm, for column 40 mm, and for foundation 70 mm. These are standard things. Along with that our IS code also has recommended some cover depth for the exposure condition. And another one important concept you should know. So when corrosion will happen, you already seen in that mechanism video, in presence of water and air only the cathodic reaction is happening. So it should have both the components, that is water and air, to start the reactions. Suppose you take this an experiment which demonstrate when this corrosion will happen. So you can see a nail which is placed in a test tube. So in this test tube they are conducting a three different conditions. So one is filled with air. Air means it should not have the humidity, it should not have moisture. So if you see that one, and if you keep the like this, means corrosion won't happen. And next one, fully immerse this needle in a glass tube filled with water. In that case also corrosion won't happen. But if you see a third case where partially filled with water and partially filled with air, in this condition only corrosion is happening. Okay, so this is very important. Only with the presence of both water and air only corrosion will happen. If you stop any one, then it will corrosion won't happen. Okay, mainly concrete is a porous material where easily it has excess of water and air during rainy season, and then once the reaction is started, then the mechanism will go up to the end where the reinforcement is fully eaten away. Okay, so and this will move on to the next slide. And also, as I already told in previous slide, okay, concrete is a porous material. So if you fill this force with the fly ash, so nowadays you might have seen in market the availability of Portland Pozzolana cement, PPC. Okay, so this is the cement which has been selling. So in this type of cement it has some percentage of fly ash. Our IS 10262 2018 recommend 30 percentage of fly ash can be added to the OPC cement. So if you add this type of cement this fly ash to the cement means it will fill in that pores, and also it will create a secondary CHS gel, so that all the sport space will be blocked, and it won't allow the entry of water and air to reach the reinforcement. So this is also one method of controlling the corrosion. So only the durability is automatically improved. And next one is hot dipped galvanizing. So this is a process we might have seen in many electrical poles. What they'll do means, if you do a normal painting, okay, with zinc, you know about that zinc primer and all, what will happen means, if you do a normal painting by manually means, okay, we can see some pores will be visible, thereby corrosion will try to initiate. Instead of that, if you do like a process in a industry, that is, first what we have to clean the surface of that steel rod or the electrical pole, okay, by means of degreasing. Okay, so initially if any grease material is there, that one you have to degrease it, and then we should go for rinsing of that to remove the material which is used for degreasing, and then pickling means, okay, we will be using some acid, mild acid, so that the surface which is smooth is made rough. Okay, some small cavities, pores will be formed, so that the zinc which I'm going to apply it can fix firmly. Okay, and after that also pickling, this acid should be removed. That one is once again rinsing with the normal, okay, neutral water, and then flush. Okay, flush is nothing but an type of material which will allow strong bonding of the zinc. You already know about this soldering. Whenever you do a soldering, you will have a solution, okay, a dark yellow color or a golden color solution. Okay, so whenever they want to just make a soldering mean, they will just dip this in this solid, okay, semi solid material, and then if you just heat it with that okay, zinc material, it will easily bond to that. So like that we have to apply the flush. Okay, flush, if we apply only, the bonding will happen, and then we should dry it. After drying it, we have to dip it in the molten zinc, so thereby it will have an uniform coating, okay, of that zinc to this one. So only it is called as hot dip galvanizing. So here we can get 99.9 percentage free of pores, so thereby the process of corrosion or the corrosion happening can be reduced. Okay, next one is corrosion inhibitors. So this one can be done in the starting state itself when you make a concrete. As I already know, this anode, cathode, electrolyte, these three are the main components. If any one is stopped or arrested means, then this corrosion won't happen. So based on that, okay, we can either stop the anodic formation, that is called anodic inhibitor. We can use calcium nitrate in that, okay, or sorry, or we can go for cathodic inhibitors. So cathodic inhibitors means it will stop the formation of cathode, mainly sodium hydroxide, or mixed means bipolar, both cathode and anode won't be formed. So among these three, this mixed inhibitor has been recently invented. So if you use this benzoate in the concrete means, it won't form both. So which has advantage uh, of the previous two inhibitors, that is anodic and cathodic inhibitors. So if you mix along with the concrete this benzoate powder means, then the possibility of corrosion happening in the reinforcement can be minimized. Okay, next is alternate reinforcement. This is also another one method. So normally we'll use steel. Okay, steel has iron which will corrode easily. So instead of that, if you go for the stainless steel where the presence of chromium is more, or this fiber reinforced plastic rebars where no trace of steel is there, so if you use this one, then corrosion can be alternatively prevented. So nowadays this fiber reinforced plastic are in practical application, mainly in the pavement and all they are using in buildings and all near the coastal region. Now they are bringing into practice, but still it should be more popularized, so that in other places they can use this fiber reinforced plastic. Okay, so you might have know about this Petronas twin towers in Singapore, and this United States Air Force Memorial which is near to the beach area. So the in these two tower and this memorial, they use this stainless steel. So thereby the corrosion can be prevented. Next one about steel coating. You might have seen in Chennai near the coastal regions. Okay, you can see this type of green coated bars. It is nothing but an organic coating made up of epoxy powder, or sometimes you can go for metallic coating. Normally we might have applied primers, zinc primer, okay, will be applied, and then only the normal paint will be applied. So like that metallic coating we can do, like zinc, thin, other materials, or this organic coating also we can give it. Okay, so now we will see in detail about metallic coating. So metallic coating will come under two. One is called sacrificial, another one is called non-sacrificial. Sacrificial coating means it will act as anode, it will sacrifice itself, and it will protect the steel. For example, this is the noble metal constitution. Okay, iron is there means if you just coat this iron with zinc, cadmium, aluminum, and magnesium means, okay, this magnesium aluminum will act as anode, it will sacrifice itself, and it will protect the iron. Suppose if we coat the iron with this brass, copper, titanium, stainless steel, which is somewhat costlier, okay, it will act as a non-sacrificial coating. So this type of material will act as an cathode, and then it will protect the steel from corrosion. Okay, so like this also we can do the coatings. Next one is organic coating. As I told, epoxy coating. So there are many industries are available, okay, all over India, okay, where they are manufacturing the type of organic coatings. It is nothing but an epoxy powder which is sprayed onto the steel. Okay, so thereby it will form a strong bonding, so it's called fusion bond. Fusion means more this epoxy will fuse to the steel, and then it will form a thick coating. So normal paint if you apply means, if you just remove it, for example a zinc, if you paint applied means we can remove it by your hand. But if you go for this epoxy means it won't come out easily. Okay, so you might have seen many construction near the coastal regions, mainly in Chennai places and all, they are going for this epoxy coated board. An IS code also is there, IS 13620, which purely debit about the process of this fusion bond epoxy coating. Okay, these are all the some of the pictures which I am going to show you, mainly in showing road, okay, which is near to the coastal region near Chennai. Okay, where the Tamil Nadu Electricity Board, okay, we are constructing some control room where this epoxy coated bar is used. And also the Neyveli Decline Corporation also, for cooling tower they are using this epoxy coated bar, because cooling tower means continuously the moisture will be there, thereby the structures, these are some of the picture, thereby the structure will try to undergo the corrosion damage, so this can be prevented. And also this IG car, Indira Gandhi Center of Atomic Research, here also they have used this type of epoxy coating rebars for the platform, where this water is taken from the sea for cooling of the nuclear power plant. Okay, so these are some of the pictures. And also in KZN also we can make use of this epoxy coated bar. Okay, this in priestess bridge also we can use it. This one is for pipe. Okay, next one is concrete coating. Okay, so instead of coating the steel, if we coat the concrete, then it will come under concrete coating. So mainly this concrete coating is divided into three. One is organic, cementitious, and hydrophobic. Organic coating means epoxy will come, polyurethane coating you can do, or cementitious means cement based coatings we can give, polymer based also we can give. Hydrophobic means which is in water repellent material, mainly that silicates based components we can use it to coat it. Okay, so before closing it, okay, the important quote, prevention is better than cure. So when you do the construction, if you follow that proper cover depth, if you use this type of inhibitors and proper workmanship, concreting practice, good concreting practice if we follow means, we can prevent this type of failures. Okay, thank you.